Hello, I'm going to do LeetCode hard question 212 today. Word search 2. This question is asking you if you were given a board with the size m by n of characters and a list of strings of words, how to return all the words that exist on the board. And after doing this test, you will know it only cares like the unique words. It doesn't require all the words, although it's asking for a list. Yeah, so this question is actually testing on two algorithms. One is try and another is DFS, specifically with Backtrack. And there are some interesting tools you can leverage for this solution to make the code more elegant. One is set default, and things like pop, get. We didn't use get for this one, but that's the same idea to avoid key error for dictionary. And also, I personally learned what is unique about assignment in Python. So this matters when you choose to use if A is a list. You extend the list this way compared to you extend the list this way or use append. So if it's using assignment, it will only look for local variable, which may cause error if your variable is on outside enclosing scope. So this one will look for everywhere. So it's pretty interesting. So the solution has 3 steps. You put all the words into the try. Put words into the try. The second is you define your DFS search. And the last one is iterate the board and collect all the words using the tool. So before that, of course, we need to initialize some variables. We know we need a try, and we know we need a return variable since it's not in place, and it's already defined here. It must be a list, and it also convenient to have the length of the row and the length of the column. And since I already did this question, it didn't have special case where the board is 0, so I'll leave this as it is. It doesn't have a counter case to handle here. For the try, we need a node to keep digging into the try when new letters coming in from the word. So we just iterate all the words and iterate all the letters, then use a new pointer called a node to update this try, which is just a nested dictionary. This is where this method of dictionary comes very handy because it returns the object directly, so you can save a line. You don't have to update it, then reassign. You can do them in one line. And in the end, remember the try, we need to differentiate between a prefix and a whole spelling of the word. So when you reach the end of this word you want to mark it, potentially it has a deeper words, but at least on this level we can declare we find a word. So at the end you want to have special mark here. You can choose whatever. I choose a $sign, and you can just use a Boolean or whatever value. But later I will show you it's very smart if you store the whole word here. So when you do DFS, you don't need to go back to reassemble all the letters. You can just use it at the end of your journey. Then you can look back at the whole map. You don't have to look back. So this word is like trace back everything for you. Very nice. Then you define your DFS. For DFS, we need the location of the cell, which is the row and the column index, and the current level of the node, which is this node. So we want to save the current letter of this location. This is not just for cleanness of the code, it's actually necessary for the backtracking. I'll show you later. Then the idea of my DFS is you check whether this letter in the cell worth exploring before you enter it. So that means once you enter it, you don't need to check again if it exists in the node. You only need to check if the current letter is the end of the current word. If that is the case, then you need to add it to the return variable, which is found here. So we want to check if the current word, I call it W, exists, is ended. So that's where the pop comes handy, because the pop lets you have a default value. You can put a false here to make it different for if condition when you check with a string. So if it is the end, then this should be true because it's not an empty string. Then you want to append it to your whatever return variable you defined. And here is a part that it's better written this way than you may want to write this way. So this will only look for local variable. If you write this way, before it you have to also declare this is non-local found, and that's not clean as this one. Now we can look around the 4 directions if we can enter the next cell. And we want to check 2 conditions. First, the index must be valid. And the second is the current letter exists in the current level of this node or try. So I'll put it here. If the row is valid and the column is valid, and the current letter exists in the current level of try, then we want to enter next level of DFS. So it does come hand to, you don't need to repeat the code here, but the main purpose of defining the create another variable for the letter is when we use backtrack. First, I want to compare this backtrack solution to, you can use another way. You can create a variable called a scene and track all the locations you visited. But then you need to keep passing them, and it just turns out slower. So a cleaner way to do this is to use backtrack, which means you change the board into a variable that you know your DFS won't enter. For example, pound sign, and after you did all the exploration, then you change it back, rather than keep tracking of every single location. And this is the reason you must put this letter into a separate variable. So with all the tools we already defined, we can just collect all the words there. And then we return. Sorry, this should be the new letter. Because when you enter next level, you want to be the current, so basically when you enter here, it's always on the same level of the node. You can do the parent as well, as long as they are consistent. Okay, let's try this specific one. Yeah, so this is a basic solution, but there is a trick you can do to speed up the solution, which is, this is really specific for this question though, is you can, after you find the word, you can delete the word from your dictionary, your try. I can do this very quickly. So basically you have to pass in the parent and delete the current. You have to keep access to the parent to delete the current. So from here, you are not passing the same level, you are passing the parent level. And let me refactor it. So the current node will become, and so similar here, it will be a level up. And oh, it's just the current level. So what you want to do is to delete it once you finished the search. So that can save you a lot of time because they have a lot of test cases where there are repetitive words in the board.